Hi folks, Internet of Things automatic detecting whether our air compressor tank is automatically draining or not with text message alerts. Welcome to another Wednesday widget. This is awesome. So air compressors create moisture, more so when you're in a humid environment or humid climate. Luckily, it's an easy problem to solve. You just put one of these relatively inexpensive tank drains or auto drains on it. But we've been using these for about 7 years and I've just never felt like they were reliable, partly because sometimes I'd walk up to it and think, I don't think I've heard it go off for a while, and I'd manually hit the button and you'd have all this water come out. And that tells me it wasn't working because it shouldn't be holding that much water, especially now in the winter months. So what's the solution? This. It's called a particle photon. Think of it like an Arduino, but with Wi-Fi and Internet of Things capability. We've got it controlling a power tail and an Adafruit flow meter. There is a photo cell on it. That looks to see if the shop lights are on. Then we need a timing element. And Arduinos and similar devices, they don't have clocks. They don't really know what time of the day it is. And doing really long delays isn't always the best thing. So that's where IFTTT or if this then that comes in. We're actually using it for two different things on this project. The first example is the time. So we just have it set up for every hour. So the code looks to see if the shop lights are on and it happens to be on the hour. We could change that interval. Then the Arduino or particle is going to trigger the power tail. That is a way to control this 110 AC device that's going to open up the drain, or it should open up the drain. But I want to test not whether the drain was supposed to open up, but rather are we actually getting the airflow, because that's what I care about. So we found this $10 Adafruit flow meter. We wide off our valve. We put a quick filter in there to make sure we're not sending a bunch of particles or bad stuff into that flow meter. And that's the check. So if the power switch tail triggers the auto drain to drain the tank, but the Adafruit flow meter doesn't detect any actual airflow out, then I get a text message on my phone that the system failed. That is awesome, and that's also something that's actually really easy to do with if this then that. And then finally, we repurposed a shallow bin, one of the red bins that we use for shop organization, into a manual override switch so that if we want to just automatically drain or test it, you just hit a button. Awesome. First up, let's machine a base that's going to hold our particle photon, our power tail, and our liquid flow meter. Basing it off 2,500 RPM, about 2.5 thou feet per tooth or 20 inches a minute. And then a quick spot and a quick drill. That then lets us adjust the mod vise. This is our new product that we absolutely love using and then we're gonna hold a fixture. So let's make that fixture. If you're out of x-axis travel, but you need to face something, under passes, adjust your pass direction to 90 degrees, and that will make it face in this y-axis direction, which can really help maximize your machine's ability to, again, use a larger tool and face this part off. Doing a quick adaptive with our go-to Tool 31. Spot, edge breaks and drilling through the fixture. If you want to see the speeds and feeds, click on the card here over to the NYC CNC website. We've got the bill of materials for this project as well as the Fusion 360 file that you can download and go through all the speeds and feeds. Now we can drop our workpiece back onto our fixture, and we're just using cap screws that we'll put on with a nut in the bottom. Makes it super easy. Also makes it easier to reuse that fixture for a different project down the road. And with our workpiece secured, what I love about this is it's a quick setup, it's a reliable setup, and it's going to give us full access to the part profile, including to do a back chamfer at the end. Using the shear hog to rough out most of the material. Again, card here to our video and webpage on how we run the shear hog on every different machine that we've got for speeds and feeds and tips and tricks. But it's a great way to remove material, and then we'll come in with our end mill just to do the finishing work and the cleanup work. Tool 31, and the trick here is to use a 3D adaptive. It's not three-dimensional work, but 3D adaptive lets us check rest machining, which means it's smart enough to know it's only got to come in and really clean up these corners. That helps give us even tool pressure and better process reliability when we do a contour to clean up the full part profile. That way we're not diving the end mill into a bunch of extra material in these corners if we hadn't cleaned them up before. We've had our fixture plate covers out for about a month now, and we absolutely love them. It makes it so easy to keep the chips out of the holes in a fixture plate. Also easy to take that foxtail brush and just clean off your machine. And if you accidentally drop a wrench or a screwdriver or a set of Allen keys, you're not damaging anything. It's great. Some quick spot drills, then drilling through for our mounting holes. And finally, the back chamfer. So we've got a whole Wednesday widget in the works. In fact, I think it's going to be next week's episode where we walk through 4 different tools you can use to cut back chamfers. Awesome stuff. There's a couple little tips and tricks to getting the cam to work right, and there's actually a number of different tools you can use to do it, so more to come on that. So let's put it together. We've got an Adafruit breadboard that's also hosting our particle photon, which is kind of like an Arduino, but with some pretty awesome Wi-Fi, internet, and IoT connectivity. We've got our power switch tail that lets us safely control a 110 AC device from an Arduino, or in this case, the photon. And we've got our Adafruit flow meter that we're using to do the test of whether the drain successfully worked. So let's take a look at the technology behind how to make this happen. If you've never seen If This Then That, take a look at the website. They've got a ton of different things that you can do, like get automatic email alerts, automatically text you the weather if it's going to rain. The concept is if this event happens, which you say, what is this, then that occurs. So that's what we're doing here. We've got the code really well commented, and again, it's on the NYC CNC website. If you've written Arduino code before, this is going to look really similar, and in fact, it's almost identical. We're setting up some pins on the particle photon. We're setting up some values. We're doing a void setup in the beginning. What's different is you've got this thing called particle.function. And so in this case, we're setting up a function that will listen to the first if this then that trigger. What's that trigger? It's this bottom left applet for us, which is to run the drain valve once per hour. We went to search, we typed in time, and we found this date and time applet turn on an applet that runs however you want. Again, this is what's great because, Arduinos don't do a really good job at things like 60-minute delays to wait to trigger the next event. So we named it run air compressor drain valve once per hour, and then every hour on the hour. So we have this function here, hour timer for hour timer. We'll come back to this in a second. So the void loop is the code that's running all the time. It's constantly looping through. The first line is a digital read of the hour test. We're actually using that for the shallow bin button as the sort of manual trigger or override. So that will also allow the drain to function. The second if statement is looking at the sensor value. That's the photocell on top of the photon, and that's looking to see if the shop lights are on. The best way to use those photocells is to test their value relative to a threshold. Our shop doesn't have any windows, so it's pretty binary if the lights are on or off. But if you had windows or other ambient light, it's really helpful to have the photocell trigger based on an amount of light. If it sees that the lights are on, the shop is open. The serial.print lines are mostly for debugging to see what's going on as we were building out the code. So this is the important stuff. If the lights are on in the shop and it's on the hour, that could be by pushing the button or the if this then that telling us, hey, it happens to be 12 o'clock or 2 o'clock or 8 o'clock. It's going to make an attempt, and what that means is it's going to digital write our power switch tail high. That's going to toggle on the 110 AC power, which should cause the auto drain to drain. It's going to leave it on for the delay time, and then it's going to close it. So if we turned the drain on, the Adafruit liquid flow meter should have seen some flow. And these use a Hall effect sensor to basically detect if this turbine or impeller is rotating. That's programmed as an interrupt, so anytime it sees it, it counts the pulses. So if the tank was successfully drained, our pulse count should now be greater than the pulse threshold, or greater than 0. I think we actually have it as 1,000 just to confirm it really did discharge some air. We actually have this program to run twice, so if it failed the first time, if it opened the drain but didn't see any flow, try it again. Sometimes we've actually found that pushing that button twice would cause the drain to really open. And if it doesn't work the second time, particle.publish valve air error. Say that 5 times fast. So that's the second if this then that trigger. This is the cool part. If we look at my applets, if no airflow detected after 2 attempts, alert John of failure via SMS. We click on that. We're using the built-in particle if this then that. So folks, this is not hard. We look at our settings here. So the event contents air error, that's our trigger. What's the device name of our photon? And then what happens, that's kind of the bottom half here. We don't have to set anything up. We just program our phone number into the account settings for if this then that, and it will send me a text message. It just shows up. It's that easy. And finally, again, the hour timer. This is what interacts with the particle so that it receives on the hour. I believe actually the if this then that queries or tells our photon that status has been updated. This was one of the newer things to me, was it calls this as a function from if this then that. Pretty awesome. Link in the video description. Head over to the NYC CNC website. We've got examples of the bill of materials of what we used, as well as a copy of this code and the links to how you can do this for yourself, whether it's for your air compressor or something else in the shop. I absolutely love this stuff. We love our air compressor. I actually have a friend who has this exact same compressor, and they had a problem with their tank and they built up a lot of rust. Keeping your shop air dry and keeping your tank in good condition is so important. That's what's so cool about this. I feel like we're hacking life. We're getting this stuff to work for us. Hope you learned, hope you enjoyed. Take care. See you next Wednesday.